Hello students, here is one more problem for you. Find the bilinear transformation which is mapping z is equal to infinity I 0 into w is equal to minus 1 minus I 1, and also find the invariant points, or you can say the fixed points. Okay, so I have already told you what are invariant points in my previous sessions. Okay, so means the points are mapped to themselves. Okay, so that are invariant, those are invariant points. So let us write the standard form of W, which is AZ plus B divided by CZ plus D. Now accordingly, we'll just do the substitutions. Why I have brought this problem for you? Because this is infinity here. So I thought of solving with infinity in Z and also with infinity in W. Okay. So let us the given thing is what? Z is infinity. That time W is minus 1. So well, how will you put Z is equal to infinity here? It's very simple. I'll tell you what. You take Z common from here. The same transformation. Don't directly put infinity because you cannot put at all. Okay. Because you do not know what is the value for infinity by infinity. So for that reason, what we will do, we will take Z common from the numerator and the denominator. If I take Z common, I can write A plus B divided by Z divided by Z into C plus D divided by Z. Now Z and Z gets cancelled. So the same W transformation is something like this. Okay. Now in this you put Z as infinity. Okay. If Z is equal to infinity, you are having W is equal to minus 1. So minus 1 is equal to A plus B divided by infinity, which is 0, divided by C plus D divided by infinity, which is again 0. Okay. So you are having, yes, A by C. Okay. Or you further simplify it, A by C is equal to minus 1, or this implies A is equal to minus C, or this implies A plus C is equal to 0. Call this as equation 1. Okay. I hope that is clear to you. Very simple. Okay. Next, and then other points, they are just normal, I minus 1 and all. For that you need not go for such a simplification and then substitute. Okay. Always remember, whenever infinity is appearing in Z, what you will do, you will take Z common and then continue it. Yes. Now when W is equal to, okay, when Z is equal to I, if Z is equal to I, you are having W is equal to minus I. So it is minus I is equal to A into I plus B divided by C into I plus D. Okay. And when you further simplify this, take this to the left hand side. Okay. Minus C into I whole square minus I into D is equal to AI plus B you will get. Or when you further simplify this, I square is minus 1. So it becomes plus C over here. Okay. So C minus ID is equal to AI plus B, or if I rearrange it properly in order, it will be AI plus B. Take these terms to this side. Okay. Minus C plus ID is equal to 0. Okay. This is what you get. So if, again the last part, if Z is equal to 0, W is 1. So 1 is equals to Z 0, means it will be 0 plus B divided by 0 plus D. Or when you simplify this, B divided by D is equal to 1, or B is equal to D, or the equation if you write, it will be B minus D is equal to 0. So this was equation 1, equation 2, and the third condition gives you equation 3. Okay. Now what I will do is, I'll add equation 1 and 2. So adding 1 and 2. The whole motto should be what? To eliminate one of the variable or one of the unknown, so that you get 3 unknowns and 2 equations. Okay. I have got one simple equation here which I am going to use, and with 2 unknowns. Okay. So let us reduce this in that same format. Okay. So B and D is there. So I can eliminate C from equation 2 and equation 1. Just look at that. Add them both. You will get C. So if you add, it will be A plus I into A. It will be A 1 plus I you are left with. Okay. As the coefficient of A. Now plus B plus C minus C gets cancelled. Plus ID is equal to 0. Call this as equation 4. Okay. Now equation 3 can be written as 0 into A plus B minus D is equal to 0. Okay, now by cross multiplication method I can work for all the proportional values for ABD. Okay, so let us, how we have solved in the previous example, the same we are going to do here. Okay, there is not much difference. Okay, so write it the same way. So it will be 1i. So leave the column of A, only consider the quotients of B and D and write them. First equation gives you the quotient for B1, D is I. Similarly, the next equation is giving you 1, D is -1. Here the quotient for A, here you are writing 1 plus I, D is, you are leaving B. Okay, so I, next here it is 0 and here it is -1. And similarly, the quotient for D you are, is the denominator for D you are writing, leave D. So you are having what? 1 plus I and 1, 0, 1. Okay, so A divided by, equate it to some constant K. So A divided by, solve for this, it will be -1 minus I, you will get it something like this, minus B divided by minus of D divided by is equal to K. Minus sign gets cancelled here. Okay, A is equals to, equate the first ratio with K, you will get A is equal to minus 1 plus I into K. Just see that. Okay, B, if you equate this, you will get plus 1 plus I into K, and D also you will get 1 plus I into K. Now since A plus C is equal to 0, so what is C then? A plus C is equal to 0. So C is equal to minus A. So what should be C? C is plus 1 plus I into K. Okay, now I can take the transformation W, which is AZ plus B divided by CZ plus D. A value we are writing minus 1 plus I into K into Z plus 1 plus I into K divided by C value, which is 1 plus I into K into Z, plus D value 1 plus I into K, something like this you get. Okay, now I can take a 1 plus I into K common from both the numerator and the denominator. So 1 minus Z is left in the numerator. Similarly, in the denominator, if I take 1 plus I into Z into K common, you are left with 1 plus Z in the denominator. These two will get cancelled. The required transformation is 1 minus Z divided by 1 plus Z. I hope this is clear to all of you. Yes? Yes. So now we have to also work for the invariant points. Okay, let's work for the invariant points. So you got W is equal to 1 minus Z divided by 1 plus Z as the bilinear transformation. Okay. Now we have to work for the invariant points. To work for the invariant points, you have to refer the definition. What it says, the points, they are mapped to themselves. So if they are mapped to themselves, so you can put W is equal to Z here. Z is mapped to Z. Okay. So if you put W is equal to Z, it will be Z is equal to 1 minus Z divided by 1 plus Z. Take this bracket to the left hand side. You will have Z into 1 plus Z is equal to 1 minus Z. Z plus Z square is equal to 1 minus Z. Get all the terms to one side. Z square plus 2Z plus minus 1 is equal to 0 you will get. Okay, now you have to work for Z. Now this equation looks like a quadratic equation in terms of Z. Work for Z, it is minus 2 plus or minus root of 4 minus plus 4 divided by 2. Okay, so minus 2 plus or minus 2 root 2 divided by 2, or Z is equal to minus 1 plus or minus root 2. So the invariant points are Z is equal to minus 1 plus root 2 and Z is equal to minus 1 minus root 2. These are the two invariant points under that transformation. I hope that is clear how to work for the invariant points. All you have to do is put Z is equal to W and just work for the value of Z. You will get the value of Z. So the two values will represent the invariant points. Okay, this completes the solution for this problem. Okay, let's continue with one more problem in my next session with another format. Okay.